To compute an average rate of change, we just need familiar algebra and arithmetic. For example, suppose that you're driving a car on a straight road and you want to determine your average speed between two times A and B. Your average speed is the ratio of the change in distance over the change in time. But what if you don't want an average? What if instead you want to know your speed at the moment when t equals A? In other words, your instantaneous rate of change at A. We can't just plug A into both places in this ratio, since we get 0 over 0. So we'll need to do something else. What we do will be determined by what we want the instantaneous rate of change to be. So let's think about that for a moment. You might think that your speed at a moment is 0, since speed requires time, and an instant has no temporal extent. But think about watching the speedometer while you're driving. At the moment when t equals A, take a picture of it. The speedometer reading shown in the picture is your instantaneous rate of change at A. Now, in fact, the picture is not really instantaneous, but for our purposes here, it's close enough. The question now is how to determine that number, the reading on the speedometer, mathematically. As we saw already, we can't plug A into both places in the ratio, but we can take some really small number h and replace B with A plus h. We get a reasonable approximation of the instantaneous rate of change with the resulting ratio. Let's say that f of t is the position of the car at time t. And remember that we're assuming that the car is moving in a straight line, so the position can be determined by odometer readings. The ratio becomes this, and we can simplify the denominator to h. We can't set h equal to 0, but we can take the limit as h approaches 0, and that's how we define the instantaneous rate of change. And we get the following definition. The derivative of f at a, which we denote by f prime of a, is the limit as h approaches 0 of f of a plus h minus f of a all over h. A function for which this limit exists is called differentiable at a. We can extend this definition a bit. A function that's differentiable on the interval I is a function that's differentiable at each point in I. And usually, when we say that a function is simply differentiable, we mean that the function is differentiable at every point in its domain. Let's look at an example. Let's suppose that the position of the car after t seconds is given in feet by f of t equals t squared, and we want to know how fast the car is moving when t equals 5. Then we're looking for f prime of 5, which by definition is this limit. We can simplify the numerator to 10h plus h squared, and this limit equals 10. So the car's speed at t equals 5 is 10 feet per second.